Hey everyone, it's Mr. Glover here. I'm just about to do the next video lesson. So the topic today is on permutations of different objects. So if you recall back to last class, we learned what a permutation is. We learned that a permutation is an arrangement of objects, but it's got to have a definite order. And that is what makes a permutation a permutation. The order matters. So remember the example I gave was words or names. The way that you order the letters changes the word. So let's go through some ideas with permutations, and we're going to build a formula so that we don't have to always do this using the counting principle. So if you had 5 or 7 different books, how many ways could you choose 3 of them? So now, if you're using the fundamental counting principle, we would have 3 books. Those 3 books can be any of our options. So the first book could be any of the 7. The second book could be any of the others, so there would be 6. And the last book would be any of the others, which are 5. If you multiply all those together, that's going to give us 210 permutations. Now, how about we try to figure out a formula for this? So 7 times 6 times 5 is an awful lot like 7 factorial. Except it's also going to be, you're going to have to eliminate every option past 4. So 4, 5, or 4, 3, 2, 1 aren't part of it. So we can call it 7 factorial over 4 factorial. Technically, this is going to be 7 times 5 times 6, or sorry, 7 times 6 times 5 times 4 factorial over 4 factorial, and those are going to cancel out. So the 7 factorial over 4 factorial actually is the same as 7 times 6 times 5. This gives us the basis for a permutation formula. And so the number of permutations of n objects taken r at a time is given by the formula NPR, that stands for n permutation r, and the formula itself is n factorial over n minus r factorial. And in this case, n is going to be our total number of objects. Total number of objects. While r are going to be the number of selected objects, or the number of objects we're choosing. Number of objects selected. All right. So let's put this to the test. How many ways can you arrange the letters of the word notes, N-O-T-E-S? So we've got 1, 2, 3, 4, 5 letters here. So n equals 5. And in this case, we're using all 5 letters, so r also equals 5. So what we're doing is 5 permutation 5. 5p5 is 5 factorial over 5 minus 5 factorial, which is like 5 factorial over 0, which is simply 5 factorial, which is 5 times 4 times 3 times 2 times 1, or 120 ways. What if you only want to use 4 letters, though? In this case, n is going to equal 5, but r is going to equal 4. So if we want to do the permutation formula, we're doing 5p4, and that's going to equal 5 factorial over 5 minus 4 factorial. Technically, it's going to be 5 factorial over 1 factorial, which is actually the same as 5 factorial. Again, 5 times 4 times 3 times 2 times 1. So again, we have 120 permutations. All right, so question C is a little bit trickier because there's some restrictions now. All 5 letters are used, however, the vowels have got to be together, which changes the way we have to approach this. So the idea or the strategy we're going to use is that we're going to lump all vowels together and treat it like it's one letter. So if our word is notes, then O and E are the vowels. So we're going to take O and E, and we are going to call it X. Now what we're going to do is we are going to figure out the number of permutations of N, T, S, and X. So find the number of permutations of N, T, S, and X. After we've done that, I guess last step, we are going to multiply this number by the number of permutations of O and E. All right, so if we want to figure out N, T, S, and X, there's 4 letters, so it's kind of like 4P4. And we can actually calculate this on our calculator. We don't need to do it by hand every time. So if you go underneath the math menu again, it will bring up a tab under the probabilities header, NPR. And so I can simply go 4P4 on my calculator, and I will find that there's 24 permutations. And now if I do the same thing for ways to rearrange the letters O and E, it's going to be 2P2, which 2P2 is going to be 2 ways. Technically, we could have just gone OE or EO. Those are our only ways. But we can calculate it this way. So if we want to find the total number of combinations, we have to take the 24 ways to rearrange these letters and multiply by the 2 ways to rearrange these letters. 24 times 2 gives us 48 permutations. And that's going to be our answer. So it's a little bit tricky. Because we lumped the vowels together, we had to treat them like one letter. We then took the 4 letters, or we can call them letters, and we figured out the permutations of those options. But we then had to go back and multiply by the number of ways we can rearrange the vowels. So same idea, using all 5 letters, but now the consonants are together. So in this case, N, T, and S are going to become one of our letters. N, T, and S, we're going to call it X. So now the only letters we have left are going to be O, E, and X. There will be 3 permutation 3 ways to arrange O, E, and X. And 3 permutation 3 is equal to 6. We then have to figure out 3 permutation 3 ways to rearrange our N, T, and S. So 3 permutation 3 ways to arrange N, T, and S. Again, there's going to be 6 ways. So when it's all said and done, the total is going to equal 6 times 6, 6 ways to rearrange all of our letters, and then 6 ways to rearrange the consonants. So we will have 36 permutations. So this permutation tool actually becomes a really powerful tool for us because we can simply calculate the number of ways to select our number of objects from n. And if we can do it on our calculator, we can do it fairly quickly as well. So, on your own, how many ways can a president, vice president, and secretary treasurer for a high school grad committee be selected from 58 students? So, at the start of every question, we want to figure out what is n and what is r. In this case, we've got 58 students, so n equals 58. We are selecting a president, vice president, and secretary treasurer. We're selecting 3 of them. So r equals 3. And then the last question we're going to have to start asking ourselves is, does the order matter? In this case, we've only talked about permutations, so yes, it's going to matter. But we will learn about something called the combination where the order does not. So for this question, since the order matters, we're doing 58 permutation 3. 58 permutation 3 is going to be 58 factorial over 58 minus 3 factorial. We could do it by hand, or we can just punch it into a calculator. Let's do this one by hand. So this will be 58 times 57 times 56 times 55 factorial all over 55 factorial. Now we can cancel out the 55 factorials, and this will boil down to 58 times 57 times 56, which is 185,136 permutations. All right, so Kaylee needs a new password for Instagram. The password can use digits from 0 to 9 and or letters from the alphabet. The password is case sensitive, so she can use both lower and uppercase letters. The password must be at least 5 characters and a maximum of 7 characters. Each character can be used a maximum of 1 time in the password, so there's no repeating how many different passwords exist. So this is kind of a tricky question. There's a lot of information packed into this. First thing we have to do is we've got to figure out how many numbers are there and how many letters are there. So if we have the digits from 0 to 9, 0 to 9 gives us 10 numbers. And now with our letters, there's 26 letters in the alphabet. However, we have the option to use both lowercase or uppercase. So lower or upper case letters gives us the option of having 26 plus 26, or 52 letters. Right. So if we add all of these up, we've got 62 things to choose from. We've got 10 numbers and 52 letters, so we've got 62 total characters. Oops. All right, so it says the password is case sensitive. She can use both lower and uppercase letters. The password must be at least 5 characters and a maximum of 7 characters. Each character can be used a maximum of 1 time. How many passwords exist? So we have to split this up into cases, because she could choose a password that's 5 digits long, or characters, 6 characters long, or 7 characters long. So we're going to have to break this apart into cases. There will be the case where there's 5 characters. There will be the case where there's 6 characters. And there will be the case where there's 7 characters. These are all possibilities. She can't have 4 because the password can't be any shorter than 5. So now we can actually use the permutation formula to calculate these. For 5 characters, she's choosing 5, or 62 permutation 5. For 6 characters, she's choosing 6, or 62 permutation 6. For 7 characters, she's choosing 7, so 62 permutation 7. We can then type this into our calculator. And we will have a whopping 2.52 times 10 to the 12 passwords. So there is a lot of possible combinations for passwords, and it really comes down to how many numbers we're choosing from. If we didn't have uppercase and lowercase, this would dramatically lower the outcomes, which is why people make passwords with upper and lowercase numbers. Okay, Fort Motors is having a sale and wants to set up a curbside display. They have 7 trucks to display, 3 red and 4 other. The trucks must be parked so the 2 red are on the ends of the row and 1 red is in the middle. How many ways can the trucks be parked? So now, this is a question where it's not going to be very easy for us to use the permutation formula. Technically, we can, but we can also solve this with the fundamental counting principle, and that's what I'm going to do. So I'm going to lay out 7 different blanks, 1 for each truck. 1, 2, 3, 4, 5, 6, 7. And now I'm going to start filling in what has to be in each of these blanks. So I know that there's 3 red trucks, and there's a red truck on either end, and there's 1 in the middle. So there's a red truck here, a red truck here, and a red truck here. I know that any of those other spots can be the other colored trucks, so there will be an other, an other, an other, and an other. All right. Now we've got to actually fill in what these numbers are. So again, I'm going to need 7 blanks. Let's fill the red trucks in first. We've got 3 to choose from. So for the first choice, there will be 3. For the second choice, there will only be 2, and then the last choice is whatever truck is left. Again, I could have done 1, 2, and 3. I could have done 1, 3, and 2. Doesn't matter because you're multiplying all together. Let's fill in the other trucks now. So we start with 4 of them. Once we've selected 1, there's only 3 for the next choice, 2 for the next choice, and 1 for the last choice. If we go to multiply these all together, we will get 144 permutations. So let's say that you don't want to use the fundamental counting principle. Let's say you want to use the permutation formulas. They're fresh in your mind, you really like them. Why don't we figure out the number of permutations of red trucks and then the number of permutations of orange truck or other trucks, and let's multiply them, just like we did with the vowels and the consonants. So red, other. For the red trucks, there's 3 of them, and you're choosing 3 of them. So there's going to be 3 permutation 3 ways to reorder those trucks. The other colored trucks, there's 4 of them. So there's going to be 4 permutation 4 ways to organize those trucks. 3P3 is going to work out to 6 on a calculator, and 4P4 is going to work out to 24 on a calculator. If we multiply these all together, lo and behold, we still have 144 permutations. So it's going to be up to you how you want to go about solving these problems, whether you like the fundamental counting principle or whether you like the permutation formulas. You can do it both ways. Part B, what if all 3 red trucks must be parked together? How many ways can the trucks be parked? And think of the block of 3 red trucks as one object in the row. Okay, so in this case, we can solve this using the permutation formulas, and it's essentially the same question as we had with consonants and vowels. So let's call all 3 red trucks 1 truck. So we're going to take the 3 red trucks and call them 1 object. If that's the case, we now only have 5 trucks to move around. We've got the 4 others and the 1 bundle of red trucks. So this now means we've got 5, and I'll call them objects because they're not all individual trucks. We want to figure out how many ways we can order those 5 objects. So there's 5 permutation 5, which works out to 120 ways to order these 5 objects. However, just like we did last time, we have to go back and we have to figure out the number of ways the red trucks can be reordered. So the red trucks can be ordered 3P3, where we have 3 trucks and we're ordering 3 of them, which is 6 ways. So our total number of permutations is the 120 times the 6 ways we can order the red trucks. So the total permutations is going to equal 120 times 6, which is going to be 720 ways. All right, and last but not least, we can use the permutation formula to solve for n or r. So now this is the kind of problem where you're going to have to use algebra. You're not going to be given all the information. You're going to have something missing that you're going to have to substitute for or solve for. So if we know 6PR equals 30, then we can use the formula for permutations to write this out longhand. So I know 6PR is actually 6 factorial over 6 minus r factorial, which is 30. All right. And now we need to use a little bit of ingenuity here, because r is what we're trying to find, and it is locked in inside a set of brackets. Now, I know that 30 is 6 times 5. So 6 times 5 equals 30. So here's the idea. If we expand this out into 6 times 5 times 4 factorial, whatever's in the denominator has to cancel that 4 factorial, because 6 times 5 is my 30. I'm already there. So I can write 6 times 5 times 4 factorial over 6 minus r factorial equals 30, and then I can cancel those out. So why did we do that? Well, we kind of indirectly just found out that 6 minus r equals 4. And now we've got a simple equation to find r. 6 minus 4 equals r, or r equals 2. So this one's kind of tricky. We had to write out our formula, and then we had to stop and think for a second about a strategy to cancel something out so that we can figure out what r is. Let's try one more of these. NP3 is 60. So again, we're going to write this out in permutation form. So it's going to be n factorial over n minus r, which is n minus 3 factorial equals 60. All right. And now, I don't know what n is, but we can cancel out n minus 3 factorial by expanding my top bracket, or my top number. And it's going to be kind of weird. We're expanding a number that we don't know. So we're going to have to keep it really general. N is the top number. 1 less than n is n minus 1. 1 less than that is n minus 2. And then 1 less than that is going to be n minus 3. We'll leave it as a factorial. The whole thing was all over n minus 3 factorial. So now the reason we did this was because now we can cancel out n minus 3 factorial. And we're left with the equation that n times n minus 1 times n minus 2 equals 60. So now we're not out of the woods yet. We still have to finish this problem, but let's sort of pause for a second to think about what we have in front of us. N times n minus 1 times n minus 2 are 3 numbers that are separated by 1. So that's like 1, 2, 3, 4, 5, 6, 7, 8, 9. if we just try some numbers, we can figure out what n, n-1, and n-2 are. So let's give it a shot. Let's start with 1, 2, and 3, or I guess 3, 2, and 1. 3 times 2 times 1, that's 6. That's not enough. Let's try 4, 3, and 2. 24, not enough. Let's try 5 times 4 times 3. And there we go. 5 times 4 times 3 equals 60. So then what's n? N is the largest one of these numbers. N is 5. And now, if you've got extra time, go back, test 5p3. Plug in your calculator. If you do 5p3 right now, 5 permutation 3, you get 60, and we know our answer is right. So there's quite a bit of information packed into these notes. This is not a simple lesson. We talked about permutations and their definition. They're an ordered arrangement of objects. We then developed a formula for permutations that involves factorials, and we then used that formula to solve some problems. And some of those problems involved some restrictions, like keeping all the objects together. So this is going to take a little bit of time, and you're going to have to spend some time practicing this stuff, because it's not going to come easily. It's going to be one of those things that the more questions you see and try, the more they make sense when you go to do them. But if you've never tried a problem before or anything like it, sometimes finding out the solution is going to take a bit of trial and error. So I've got some questions for you to try. It's in your workbook, page 98, questions 1 to 4, 6, 7, and 10. There is another question I used to have in this note set. It was question 9. I'll leave it up to you if you want to try it, but it's kind of tricky because the cases are not as they seem. Anyways, I think I'll wrap it up here. Hope everybody has a great long weekend, and I will see you all next week. Take care.